guitar pedals sound completely different, but under the hood, they're usually built from the same exact circuit stages. And once you understand what each stage does, that's when you can start shaping your own tone. Everything starts here, because if the power stage is wrong, nothing else matters. Guitar signals are AC. They swing positive and negative. But a standard pedal power supply, like a 9-volt battery, is DC, from 0 to 9 volts. So we have to create a virtual ground at 4.5 volts, and that is what becomes our reference point. So instead of your signal trying to swing below 0 volts, which it can't, we use the virtual ground as the midpoint. And that capacitor that you'll always see in the schematic, that is stabilizing that 4.5 volt reference. Without it, your ground isn't steady, and that shows up as noise or weird distortion in your final circuit. This is the first thing that your guitar actually hits. Guitar pickups are high impedance, and they don't like being loaded down. If your circuit impedance is too low, you're effectively forming a voltage divider with your guitar pickups. You'll lose high end and your guitar starts to sound dull. A buffer solves this by giving you a very high input impedance and a very low output impedance. So your guitar sees an easy load and your signal stays intact. The buffer doesn't change your tone, it preserves it. If you're watching this video, you're probably already into building or designing your own guitar pedal circuits. And there's no better way to take it to the next level than with custom PCBs made through PCBWay. I've used their manufacturing services on projects like my clean blend circuit and my 20-part overdrive pedal. And I always feel confident sending them my designs, knowing that they have a team that will review those files and catch any potential issues before they go into production. If you're building your own pedals, I highly recommend that you check them out, and thank you PCBWay for sponsoring this segment. This is where we actually amplify the signal. With an op-amp, gain is set by the ratio of resistors in the feedback loop. You're not just making the signal louder, you're increasing its voltage swing. And that matters because distortion doesn't happen until you hit a limit. So this stage is really about pushing your guitar signal towards clipping. This is also where a lot of pedals shape their feel. By using a fixed resistor in the feedback loop, we can set a minimum amount of distortion, and the potentiometer size sets the maximum amount of distortion. So after implementing the gain stage, here is an example of a low gain setting. And now if I turn the potentiometer to increase the gain, we're going to get something like this. If you're enjoying content like this, subscribe and give this video a like. It really helps out the channel. Now to the next stage. This is where distortion actually happens. The diode set a maximum voltage, basically a ceiling for your guitar signal, and when that signal tries to get past, it gets clipped. But not all diodes clip in the same way. Each type of diode has a different forward voltage, and that's the point where it starts conducting. So a lower forward voltage means your signal gets clipped earlier, giving you softer, more compressed distortion. And a higher forward voltage lets more signal through before it gets clipped, which feels louder, more open, and more dynamic. There are two main ways where these clipping diodes get implemented. To ground, which gives you a harder, more aggressive clipping, or in the feedback loop, which is softer, smoother, and typically more compressed. I'm going to use diodes in the feedback loop, which gives you a softer, more compressed tone. So again, here is our tone after the gain stage, but with no clipping diodes. Now I'm going to put the diodes into the circuit. Now here's our tone. This is the most underrated stage in a pedal. Clipping creates a ton of high frequency content. Some of it sounds great, and a lot of it doesn't. So filtering is what decides what actually makes it to your amp. At its core, this is just frequency dependent attenuation. Capacitors pass high frequencies, and resistors control how much gets through. Here are the two key roles. Pre-clipping filtering shapes how distortion behaves. You can cut bass for a tighter distortion or keep bass to get a fuzzier tone. Post-clipping filtering shapes the final tone by removing harshness, and it really defines the voice of the pedal. Now we have independent control of our treble and bass cut. This is often the difference between something sounding harsh or polished. Last step, set your final level. This is just a variable voltage divider. You're controlling how much signal gets sent to the output versus to ground. This is also where you match unity gain, or you can push your amp harder. Now that our effect shaping is complete, we need to send the signal out of the circuit properly. By this point, your signal has gone through multiple stages that can increase impedance. If you send that straight out, you can lose signal strength, especially through cables or other guitar pedals. So we use a low output impedance stage to preserve the signal strength, prevent tone loss, and keep the pedal consistent through different setups. Now let's combine each of these different stages and see how it comes together to give us our final effect. Every analog dirt pedal you've ever used is some variation of these 7 stages. The difference comes down to how each stage is tuned and how they interact with each other. Once you understand these building blocks, you can start experimenting. Swap component values, try different op amps, tweak the clipping, and take circuits you already like and turn them into something completely your own. If you're into this kind of content, consider subscribing and dropping a like. It genuinely helps out the channel. That's it for this one. Let me know what you want to see next in the comments down below.